All right, welcome. We're going to multiply polynomials again. This time we're multiplying binomials times like multiple term polynomials, and we're going to look at some special cases. Our goal is to multiply different polynomials and recognize special cases. I like this joke over here by my man, Gene Wilder. It's not by him, it's just a meme. I like polynomials to a certain degree. All right, let's get started. Recap. FOIL. We got first, outside, inside, last. And what that looks like, x times x is x squared, x times 3 is positive 3x, 2 times x is positive 2x, 2 times 3 is positive 6. Let's combine like terms, x squared plus 5x plus 6. I bet I did that slower than you. We remember FOIL. Can FOIL work when one of the polynomials is bigger than a binomial, say a trinomial, or a 4-term polynomial? Let's find out. Can I FOIL with this? Well, if I do first, outside, inside, last, well, I have a first term, and then I have outside terms, but what do I choose for the inside? And then I have a last. So when one of the polynomials, or both, are bigger than binomials, we can't really just FOIL. We're actually just going to distribute. So this time I only use red and blue because I'm going to distribute x to x squared, and then also to positive 3x, and then also to negative 4. And then I'm going to distribute 2 to positive 2 x squared, to positive 3x, and then to negative 4. So I'm really just distributing these two terms, but I'm going to do it, each of them 3 times. So let's see what we get. So here I have x cubed plus 3x squared plus 6x in red because these are the result of x multiplying to each of these terms in the trinomial. And then in blue, 2x squared plus 6x minus 8. These are the 3 terms I get when I distribute positive 2 to the 3 terms in the trinomial. Here I've rearranged the polynomial and put like terms next to each other. Same variable, same exponent. Here I have same variable, same exponent, same degree. And now I've simplified it and I have x cubed plus 5x squared plus 12x minus 8. So this is what we're doing when we just distribute. I'll write out the terms after I do the multiplication. I'll rearrange them so I can easily see which terms I'm going to combine using addition or subtraction. And then I have my simplified answer. So now I have 2x plus 1, and then there's a binomial, times a trinomial, x squared minus 3x minus 7. And we're going to try the box method. Here's the box. I've already drawn it with the grids. And you'll notice when I write it, I include the sign. So I have a plus 1. I just make sure it's positive 1. I have minus 3x. I'm going to treat it as a negative 3x. I have minus 7 right here. I'm going to treat it as a negative 7, my constant in my 2 variable terms. So now I'm going to just do the multiplication, fill it out like it's a times table. So we have it filled out, right? Inside the box is the product from the top of the column and the row. So 2x times x squared is 2x cubed, and so on and so forth. So you'll notice this is my only x cubed term. But if I go diagonally, I have like terms right here. They're both x squared. And then likewise, if I go here, they're both x to the first power. Sometimes it works out that way, that it's organized very well, and it's easy to see which terms we're going to combine. So as I move, I have 2x cubed. There's no others, so I wrote it down here. I have negative 6x squared plus x squared. I'm combining them. So I get minus 5x squared. I have negative 14x here, and that combines with negative 3x, which gives me negative 17x. And then I have negative 7 as a constant, which is done. So now we have a binomial, second degree, x squared minus 2. And then I have a trinomial, also second degree. And we're going to use a vertical method. So I'm going to line it up vertically like we would do multiplication with multi-digit numbers. And I want to talk about this. I can't just do x squared minus 2. Because this polynomial is missing something. Just like 509 is not the same as 59. The difference is there's a placeholder for the tens place. This means I have 5 tens. This means I have 0 tens, but I have 5 hundreds. Something similar with polynomials. So when I write it out, I have x squared plus 0x minus 2. This way, when I do my multiplication, all my places line up. I have my x to the 0 exponent, to the 1 exponent, and to the 2 exponent, all lining up where they belong. We're going to color code this one. So our x to the 0 will be red when we multiply times that. That will be blue, and then x squared will be green. So here I've multiplied it all out. Negative 2 times 5, negative 10. Negative 2 times 2x, negative 4x. Negative 2 times x squared, negative 2x squared. Then I move over, because now I'm going to be multiplying times the x to the first power, this place. So I have 0x, everything's just going to be 0, 0x, 0x squared, and then 0x cubed from 0x times x squared. Then I have to move over twice, because now I'm in the x squared location. X squared times 5 is 5x squared. X squared times 2x, 2x cubed. X squared times x squared, x to the fourth. And now we add, and here we have it simplified. We just add vertically. Negative 10 drops down, negative 4x plus x, 0x, negative 4x, and so on. Okay, and this is our simplified, completed answer. So which method is best? Is it best to just distribute and rearrange? Is it best to use the box method? Is it best to use the vertical method? Well, I would say the answer is yes. All three. Because ultimately, the method that's best is the one you are most comfortable using and the one that you practice the most. Because the more you practice with, let's say, just distributing and rearranging, you'll become more comfortable with it. Or if you use the vertical method over and over and over again, you'll become proficient and it'll be the most comfortable for you. And so therefore that would be the best for you. Or the box method. It really depends. I would suggest you try all three and then choose the one you think you're going to like the most and then just use that one on the next few assignments. Three special cases: x plus a squared, x minus b squared, x minus a times x plus a. A and b could be the same number, but they're all just going to be integers or even real numbers for this exercise. So I expand it out, then I do FOIL, and I multiply everything together. I get x squared plus ax plus a squared. I simplify by combining my like terms. I get x squared plus 2 times a times x plus a squared. What does this look like with numbers? Well, if I chose a to be 3, I get x plus 3 times x plus 3. That's the same as x plus 3 squared. I FOIL it out, and when I add these two together, I get 6x. Well, if you notice, 6 is really 2 times 3. And so this is our rule. This is a good shortcut to know when you have this form here. So what does it look like when we just change the sign from plus to minus? Well, I expanded out, x minus b times x minus b. I did FOIL, x squared minus bx plus b squared. Then I combine like terms, x squared minus 2 times bx plus b squared. What does that look like with a number? So we use the same numbers we did before, 3. But this time I'm doing x minus 3, okay? I do FOIL, x squared minus 3x minus another 3x plus 9. When I combine my like terms, I get x squared minus 6x plus 9. You'll notice negative 6 is the same as 2 times negative 3, so which is what I have here. So we're all done. So what happens if the signs are opposite? X minus a times x plus a. FOIL it. X squared plus ax minus a squared. When I combine like terms, these cancel, and so they go to 0. Then I'm left with x squared minus a squared. What does that look like with our number 3 that we used for the other two examples? X minus 3 times x plus 3. FOIL it out, I get x squared plus 3x minus 9, because positive 3 times negative 3 is negative 9. These cancel when I combine, I'm left with x squared minus 9. So I am done. So to recap, when we multiply polynomials, we're just using the distributive property over and over and over. But the methods, rearranging, box method, vertical method, they are all distributing one polynomial through another using multiplication. All it is, or how are we going to organize and keep track of what we're distributing, what the products are, and how we're going to combine like terms. You have to decide which method is going to be best for you. Choose one, practice it ad nauseum, which means just over and over, and you'll become proficient, and that will be the best method for you. Again, our assignment, if you're one of my students, you got a worksheet, 7.3, multiplying polynomials times polynomial. Did you know I have 2 cats? Anyway, hope this video has been helpful. If you have any questions, you know how to get a hold of me. Good luck.